All right, so the last two, I cut off my last video too early. That's okay. So the directions are on a previous page of mine, but we are integrating using division. So when I divide by a quadratic, we just need to be careful. We've seen this now a couple times, that we use a placeholder. Let's see, if I have a t to the fourth and I'm dividing by a squared, my answer is going to be a t squared. There we go. I need a column for my t squared term. I'll need a column for my linear term, a column for my constant term, and then perhaps a column for any remainder. All right, here we go. So t to the fourth means I need a t squared up top, and now I start multiplying. And that's going to set up my diagonal. Right now I don't have any t cubes, but I need 3 of them, which means up here I'm going to need a 3t, which means here I have a 0t squared and a 3t. And that sets up my next diagonal. And I already have 1t squared. I don't need any more t squareds. So I'll need a 0 up here, which is going to give me a 0t and a 0. All right, let's take a look at this diagonal. Right now I have 3t. I don't need any more t's. That's okay, that's just my remainder. And right now I don't have any constants, but I need a 1. Okay. So this fraction can be rewritten as t squared plus 3t plus 0 plus, and my remainder is 1. And now we're looking at 3 individual terms. The antiderivative of t squared is t cubed over 3. The antiderivative of 3t to the first is 3t squared over 2. And then this is the derivative of inverse tangent of t. And it did not have any bounds, so plus c. All right, last one. So here the directions changed, and I want to evaluate by completing the square. Oh my gosh, look, there's no dx at the end. That's poor form. Sorry about that. All right, so this is the quadratic. I want to complete the square with the quadratic, so I might actually just go over here and just kind of give myself some space. I didn't even give myself enough space. The question is, what do I really want there? And if I add a number there, I'm going to need to turn around and subtract it. All right, so the rule is we're going to take half of the 8 to get a positive 4, and then we square it. And if I add 16, I need to turn around and subtract 16. But the whole point is that these 3 terms now create a perfect square trinomial. You can factor that into x plus 4 times x plus 4, which is x plus 4 squared. When I combine my constants, I have a plus 1. All right, so in my integral, I have a negative 3 on top, and then my denominator is really x plus 4 squared plus 1 dx. Now, I should have done it from the beginning. I'm about to do it now. I am going to take that negative 3 and drag it all the way out in front. And I even just very loosely just wrote that I'm left with a 1 over something squared plus 1. Oh yeah, remember, 1 over something squared plus 1. That's inverse tangent, right? So now I see that this is something I should have memorized. So the negative 3 stays there, and the antiderivative is the inverse tangent of x plus 4 plus c. Technically, if we're reversing the chain rule, we divide by 1, right? The derivative of the inside is 1, but don't have to worry about it.